Hello there! So sometimes I sit around my office and I wonder things. So today I was wondering, what would it be like if there was a zombie attack on Ohio State's campus? I wonder who this could be.
Bart! OSU's been attacked by zombies! What are we gonna do?
This looks like a task for calculus. So we're going to try to model the zombie attack somehow. And we're going to do this in stages. So we're not going to start off with a perfect model, but we're going to start off with a basic model and see where we can go from there. So let's start with zombie prime of t. So this is the rate at which the number of zombies is growing per hour. All right, and I claim this is something like the number of zombies at a given hour times the number of people at a given hour. And I want you to think about this for a second. So think about this. If there are 0 zombies, what's the rate of increase? Well, zombie prime of t had better equal 0. Because if there's 0 zombies, then zombie prime of t equals 0. And if there's 0 people, then zombie prime of t had also better equal 0. Because there's no people to convert into zombies. So this sort of model looks good. In fact, if you think about it, when do zombies increase the most? Well, it's going to be when there's about half as many zombies as there, about half our zombies and half our people. And that's when this is biggest. It's akin to when you think about a rectangle and you think about a rectangle with a given perimeter. This rectangle has a small area, this rectangle has a small area, and this rectangle has a very large area. So this kind of makes sense. Of course, the number of zombies isn't just dependent on this. It's going to be dependent on something else. It's going to be dependent on people, because people are eliminating zombies. So we have, this is the zombie, they're making zombies, and this is eliminating zombies. So it's a minus sign here. And then there's going to be 2 coefficients, C and D. And these coefficients are difficult to determine. But I think that David and Sean can help us. But what are the coefficients? So what's it look like out there?
These zombies look pretty aggressive.
Yeah, I'd say the first coefficient is 0.0001.
And by the looks of things, it looks like it will take 5 people to take care of 1 zombie. So 0.2.
So from Sean and David's work here, we have a coefficient of 0.001 in front of the zombies and times people, and a coefficient of 0.2 times people of t. Now all we need to know is how many zombies there are out there and how many people. Well, it looks to me like there's let's see, it looks to me like there's basically 2,999 zombies out there. I know. I've got an eye for numbers, people. Let me just tell you. And it looks to me like there's 7,150 people out there. That sounds pretty good. Lots of people. Minus 0.2 times 7,150. Right now, this is the number that's out there. Okay. And what does this mean? What does this even mean? Well, I have my trusty calculator here, and so I'm going to do 0.0001 times 299 times 7,150. Okay, and I get this is equal to 2,144.285 minus 0.2 times 7,150. 1430, and let's see. Oh my goodness. 714.285.
Oh, rats. This is bad. The zombies are growing at a rate of 714 zombies per hour. This is really bad.
What are we gonna do now?
So what do we know?
Well, zombies, they have no brains.
Oh, so we can use calculus
Textbooks!
to beat them up!
Yeah! Especially the Mookless textbook.
So what's the situation now?
Well, the coefficient is still 0.0001.
But now I see it takes 2 people to beat up 1 zombie. So 0.5!
But in all this talking about calculus, we neglected to take care of the fact that the zombies are still out there converting people into more zombies. So now, it looks like, according to my calculation, there's only 5,006 people and there's 3,713 zombies. Rats! What are we gonna do?
Okay, now we're using Sean and David's new data. Okay, so the people are using calculus and calculus textbooks, and so this coefficient has risen. However, not all is good on the campus of The Ohio State University, because in the meantime, since we've been chatting about calculus, the number of zombies has risen from 2,999 to 3,713, and the number of people has decreased to 5,006. Oh shoot, what's going on here? Times 5,006. So what's the outlook at this point? If zombie prime, the rate which the zombie is growing, is equal to this, what's going on here? Well, I got my trusty calculator out. I'm gonna put the numbers in. So 0.0001 times 3,713 times 5,006 minus 0.5 times 5,006. Oh! But look what we have here. This is equal to minus 644.2722. This is good.
You know what this means? The zombies are now declining at a rate of 644 zombies per hour. We're gonna be okay!
Yeah!
Yes!
So now I know what a zombie attack would be like on OSU's campus. It's not something I would like, but we can model it with calculus. Let's go do some more math.